Hello everyone, it is time for another recitation. This time we're going to be going over a TODO app in React. It is not the most original possible project we could be doing, but there's a good reason for that. It covers a lot of really important fundamental topics that I want to spend a little bit more time on because I know they're a common sticking point. And it lets us talk about forms and inputs in React without that being the only thing that we do today. We'll spend some more time with forms and inputs and their quirks in React, but I want this to kind of be a bit of a gentle introduction. So what we're trying to do today is we're trying to render out a list of to-dos. I want to be able to click on them to mark them as done or as uncompleted. And I want to have an input that I can type into and add to-dos to the list. Those are the main things that I want to do. So I already have some set up here in the Git repo. Main things are that we have this array full of sample to-dos. The big reason for this is just so that when I'm constantly saving the app and the screen refreshes, that our state doesn't clear, so we actually have to-dos we can see. But two, also to give you an idea of what we want that data to be structured as. Right? There's at least one piece of information that we need for every to-do, which is its text. I've decided to model these to-dos as an object, like most data we have in JavaScript, with the text under the key title. That doesn't matter. You can call that whatever you want. In fact, I encourage you to change these up if you feel like it. Its status of being done or not. I have a key of done and a Boolean value. And then I also have these IDs here, which we're going to talk about a bit later, but they're very important. So let's go ahead and try to get these to-dos on the page. I already have some default styles here. I'm using an SCSS module to do this, and we'll be chatting about that as we go along. But let's get these to-dos on the page. So I could just reference this variable initial to-dos inside of my app component. It's just a JavaScript variable. It's in the scope. That's going to work fine. But I know that I'm going to want to be changing this array. I'm going to want to be adding to-dos to it. I'm going to be wanting to mark existing to-dos as done or not. So I'm going to go ahead and put that inside of a state variable. Right? And normally the argument that we give to use state is the initial state, and it usually ends up looking something like empty array, null, or nothing. Right? But this time we actually have some data that we're going to feed in there. I've decided to call this to-dos array, right? You could give this any of an infinite number of names. Common one we're going to see here is to-dos. The problem is we're going to be starting to call everything to-dos or to-do with varying degrees of capitalization, and that's going to get very confusing. It's still going to get confusing, but hopefully this helps a bit. We're just going to be more explicit. This is our array of to-dos, the to-dos array. So if we want to get all these out on the page, I cannot do this, right? This is not going to work. React is going to yell at me, and we're going to get this error that's going to be really, really common and a consistent source of frustration, which is that objects are not valid as React children. And these errors have gotten really good because it will try to narrow down what could have possibly happened here by telling me, right, the object has the keys ID, title, and done. There's a lot of things that React can render for us, and by that I mean put it on the page for people to see. And those are our primitive values, numbers, strings. We can have arrays of those things. React cannot do objects for us, because what would that mean? What would that look like? React doesn't know. So we have to get these into a form that React can reliably display. Because this is an array of objects, right, I want to map over it. Because what map is going to allow me to do is take an array with some data in it and transform it into an array of other types of data. So I could, for example, map over my to-dos array, get an individual to-do object, and just do todo.text. So what that's going to do, right, is originally what I have here, did this not show up? I could have sworn we can render in a... Oh, text is not a key in this array. It's title. That's what I did. Maybe that should be text. Okay, geez. Yeah, so we can render an array of strings. So I'm taking this array of objects, I'm getting each to-do object, and I'm turning it into a string. The string that I've decided to call title within that object. And we can render that just fine. And we can take out our to-do because we're done. We did the whole project. All right, but that's not quite good enough. I want these to be separated from each other, so I'm going to put these inside of a div, right? And React can certainly render an array full of elements just fine, right? And so now we have all of our to-dos here separated inside of divs. And if I were to look at my console, we're going to see that React has thrown a warning. Note that this is a warning, it's not an error, right? React will still continue to work when I have this here, but this is something I mentioned the last time we mapped over data, which is React is going to be dynamically creating all of these divs for each one of our to-dos. And when this component re-renders, React will have to do that again. And for all React is aware of, all of those are new divs. So what React will have to do is it will have to tear down the old ones, put in the new ones, and then check to see what has changed. And that's very inefficient. And that'll actually cause components to remount, which is usually not what we want. So instead, what we can do is we can give a special prop to each element rendered inside of this array called key. And what this needs to be is this needs to be unique within the context of this list, and it needs to be consistent over time. Because if React sees a div with a key of 1, this render, and next render sees a div with a key of 1, it'll know that that's the same div over time. Right? It doesn't just have to be unique, but it needs to be constant over time. This is why we have todo.id. This is one of the reasons all of these to-dos have a unique ID value, is so that when we render them as the list, we can make that error go away, right? And now React knows that this go grocery shopping is always go grocery shopping. All right, so we've got these on here. Let's go ahead and before we do anything else, let's try and get these toggling their done status. In order to do that, I'm going to need to visually represent what these look like. Now I'm just going to do a neat trick here to make this a little bit more legible. If we have our implicit return arrow function, where I don't have curly braces, I don't have the return keyword, right? It's one line. I can actually wrap what I'm returning inside of a set of parentheses, and that lets me kind of just format this a little bit neater. So what I'm going to do is I'm going to add an on-click. Oh no, I want to style these. So what I can do is I can come in here and I can give this an inline style prop. And I can check and I can say, all right, I want to give this text decoration. And if this to-do is done, right, if todo.done, I'm going to use my ternary operator. I'm going to say, if this is true, then what I want to do is I want to give this a text decoration of line dash through. Otherwise, I'm going to let it be undefined. Right, and so what the ternary is a very, very useful friend that makes new programmers very uncomfortable because it's incredibly terse, which is both a blessing and a curse. Once you're familiar with the ternary, you're going to use it everywhere because it's great. It does exactly what you need to, very efficiently. However, if you're not used to it, it looks like crazy people things, like most JavaScript, right? So what this is going to do, what the ternary operator done, is we have some expression, right? That is the first term in the ternary. And then we have a question mark in the true branch, a colon, and then the false branch. And the reasons for this are historical. The ternary operator is very old. But if the first thing here is true, then this whole statement is an expression. So it's going to be evaluated to the value of the true branch, right? What that means is if this is true, this whole section's value gets replaced by this. If it's false, we do what's after the colon, which is going to be undefined. So this allows us to set this style prop as either line through or undefined, which is going to let us put this strike through here on the to-do that we know is done. Right?
Henry?
Yes.
Would it be bad to explain to someone or equate the ternary and colon to an if-else?
Oh, yes, absolutely. That is the great context that I am missing. Yeah, so the big difference between the ternary and the if-else is what I mentioned earlier as an expression, right? So when we have an if statement, right? If something is true or false, if or conditional, then I want to run some code. This is my true branch. Else, I do my false branch, right? This is the classical if statement. The problem is, how do I get values out of this? The way that this works is this controls what code executes. It does not control what this is equal to. And that doesn't really make sense in this context because that's not what it's for. So let's say I had a variable. Let's call this variable, am I broke, right? So if my my account balance is greater than 500, then broke is false. Otherwise, broke is true. Right? So what I've done with this if statement is I've checked, the value of some variable, and I've decided to execute each section of code differently. And I could do more things in here. Like I could console log, you're all good. Right? I can do other things in here. But if I'm just using this to try to decide between two values, like here, there's a much more efficient way of doing this. And that's what the ternary operator is there for. The ternary operator is an expression. We can set things equal to it because it becomes a value. In the same way that 1 plus 1 becomes 2, right? It's an expression. This line of code here, this 1 plus 1, evaluates to 2. This if statement doesn't evaluate to something. I cannot do broke equals if statement. I don't even know what I would expect to happen here. But that's exactly what the ternary does. What the ternary allows me to do is I can declare the variable broke, and I can say if account balance, our expression, is greater than 500, the question mark marks my true branch, which is false, and the semicolon is going to mark my false branch, which is true. And what this ternary here is going to evaluate to is either false or true. Right? It is going to be substituted. This whole section of code in parentheses is going to be substituted with the value of each one of these branches, depending on what our conditional ends up being. So that's the purpose of the ternary. It lets us kind of do this abbreviated if statement where I want one value to come out at the end. So here I want text decoration, my inline style, to either be line through or undefined. And that's how I get this going here. So does that make sense?
It does, thank you.
All right, cool. We're going to be going over that a little bit more later. But I don't like using these inline style props if I can avoid it. Instead, I like using CSS and classes because that's just what I'm most comfortable writing. Today I've taken the liberty of using the SCSS modules, as I pointed out. To use SCSS, all you need to do is add known Sass as a dependency. You get this .module thing for free. And what this does is it creates an object called styles. And we can console log styles. Take a look at it. And what this ends up being is an object full of crazy class names. Right? If we look inside of app.module.scss, just a Sass file, right? Just got some normal class names in here. But what we do is we can use super generic names for our classes here, like add. And I no longer have to worry about the global scope of my CSS, because what React is going to do is it's going to say, okay, I'm going to give you an object, styles, that has a key called add, right, which is the name of the class that I wrote here. But what this class is actually going to be called is the name of our component, the name that you attempted to give the class, and then some random garbage, so that nowhere else in your React application will that class name actually show up. So this allows you to get CSS that is scoped to the component that you're writing. You no longer have to worry about global CSS bleeding over somewhere else. And that's super nice to have that assurance that we're not going to write CSS that affects something that I've never seen or heard of before. But that just means instead of writing the class name directly, I would do, for example here, styles.header, right? If I have a class name of header, styles.main for this as well. And I can do this for this div too. I can say the class name here is equal to styles dot, let's see what I decided to call it. I think it's to-do. It is. Styles.todo. And that's going to give me some nice looking to-dos. I can even do my conditional stuff right inside of here. There's lots of ways to do this, because what styles.todo ultimately is this string right here, app-to-do 3yik. But instead of bashing these strings together as myself, there's some nice libraries out there. A big one is class names, I think is just what it's called. I don't want to install a whole dependency just so I can give a React component multiple classes. So instead, in every project, I just write this one-line function that, if you've watched these videos before, you have seen it. It takes in any number of class names, right? That's what this REST operator does, is I can say cn of, first class name, second class name. What the spread operator is going to do is it's going to collect them into an array for me, right? Class names is going to be the array of 1 and 2. So this way I can filter them with what we call the identity function, right? So if it's truthy, if it has, in this case, a non-empty string value, then it gets to stay. If it's falsy, it gets taken out. And then I join them with a space in between. And that's good enough for me because it lets me do things like this. Styles.todo, call my cn function. And I'm going to say if my to-do is done, then in this case I'm going to use the logical AND operator, right? If my left-hand side is true and my right-hand side is true, this will give me the value of the right-hand side, the true value. Otherwise, if either one of them is false, then I get back false, which is going to get filtered out by my cn function. So I'm going to give it then styles.done. And it is going to accomplish the exact same thing, except it's got some secret sauce in there to give it a check mark using pure CSS that we will talk about at the end if there is time. So Now we've got some nicely styled to-dos, and we've got some conditional styles on them as well, which I think is pretty sick, to be able to build something like this very quickly, right? Very little code here. But now I want clicking on them to do things. So what I need to do, right, I know that I'm going to need an on-click event. When I click on this div, I want a thing to happen. So I'm going to give it a callback function because I don't want that thing to run right now. I want it to run when it's clicked on. So I need to give it a function that can be run when it is clicked on. What we're going to need to do is we're going to need to toggle the value of this specific to-do to true or false. Right? It's done needs to be false if it was true and vice versa. And I'm going to need to change my state variable in order to do this. So there's lots and lots and lots and lots and lots of ways to do this, right? Some of you might end up Googling things, oh, well, like, how do I find this to do in this array? And you'll come across array functions like find or find index, and those are certainly going to do some things, but I'm going to show you a very neat trick that is wonderful, because what we need, right, what we have is an array full of to-dos, right? I have an array full of these objects, and one of these, let's say this one, that one, boom, pretty cool down arrow. That one is the one that I want, right? So when I come across this first object, this first to-do, I want to leave it be. When I come across this one, I want it to be the same to-do, but with its value of done toggled. And when I come across this last one, I don't want to do anything to it. So essentially what I want is I want this array, but with one element in it changed. And what's a function that I'm familiar with that allows me to take an array and then do something to each value in it, right? Using some logic to transform it into one piece of data or another. Well, that's our friendly map function here. Here I'm taking to-dos array, and I'm using map to transform it into an array of divs. Here what I want to do is I want to take an array of to-dos, and I want to transform it into an array of to-dos, but with one thing changed. So what we're going to do is we're going to return to-dos array dot map. I'm going to take in a to-do. I'm going to call this one T here. And the reason I'm not going to call it to-do is this is very important to remember the scope and the closures of the functions we're writing here, right? You may have explicitly learned about closures. You may have seen them in a Medium article and it immediately scared you, so you closed it. They're oftentimes not as complicated as you think, right? So if I put this value of to-do here, right, then inside of this callback function, inside of this map, then the value of to-do is going to be one of the elements inside of my to-dos array, right? It is going to override this value of to-do, the one I've been using inside of this div. However, if I just change this to t or any other variable, now I can reference either one of them. I can reference this to-do, or I can reference this t. Because what I'm going to need to do is I'm going to need to check and see if this to-do, if this one in our state variable is the same as the one that we're currently making a div out of, right? The one that I have clicked on, the one whose div this belongs to. So I can say inside of this map, if t.id is equal to todo.id, then I'm going to do something. Otherwise, I'm going to do something else. Right? Here's our if statement. This is the other reason why IDs are very important, is it gives us a canonical way to compare these different objects, right? How do I know that this to-do is the one that I want? Well, it has this ID that I've decided is going to be a unique identifier that I can check and see if it's equal to another unique identifier, right? We'll talk a bit more about why we can't necessarily just do this with objects. And we'll see how that can end poorly for us. But we can do this with numbers, right? We can check and see if two numbers are the same. So that's what I'm doing here. So if these two numbers are different, right? If the to-do from this array is different than the one that I have in this div that I have clicked on, right? Then I can just move along, right? In this map, right, we're taking each element in the array and we're running this function on it. And if the to-do we're on doesn't match the one that I clicked on, well, then the map can just have that to-do back. I don't want to change it. However, if this to-do is the one that I've clicked on, is the to-do that is belonging to this div, then I do want to change it. So what I could do is I could say, oh, t.done is now going to equal the opposite of t.done. This is my not operator. If this is true, it'll make it false. If this is false, it'll make it true. Right? We can prove this to ourselves very quickly. Not false is true, not true is false. Pretty cool. You could also do this with another if statement, but this is getting long enough as it is. And then I want to return t, which I do in either case, so I don't even need it inside of my if statement. And we can see that this does nothing because I'm returning the value of this map instead of calling set to-dos array on it, right? I need to give this new array back to my set state function in order for me to see the results. And there we go, right? Now we have this working to-do list where I can check these on and off. And again, we're just using this conditional style of done and some just plain old CSS to get this neat animation going. The problem is this seems like it's working. And it is. We haven't done anything illegal. We haven't gotten any errors. But we've done a thing that I think is very bad. And the problem is that we won't necessarily realize this is bad until it causes some crazy hard to track down bugs. What we've done here is we've performed mutation, right? What we've done here is we've taken our to-do object, we've taken its key of done, and I've changed its value with this assignment here, with this equals sign. And that's fine, you know, because in a sense, that's what we want it to do, right? It was false, now it's true. I've accomplished the thing that I wanted to do. The problem is that mutation doesn't always play nicely with React. As we've seen before in either of my videos about asynchronous programming with React, the timer project or the XKCD project, the value of our stateful variables don't actually change, right? Because they're consts, right? This is a constant reference to the to-do array. The problem is all that means is I cannot do this, right? JavaScript will not let me reassign the value of this array. And that's good, because what that means is that inside of this render of this component, to-dos array is always going to be the same thing. That is, unless I do things that actually modify the contents of that array. Const doesn't give me that safety. I can, for example, take one of the objects from that array and change a value in it, right? And then suddenly to-dos array is no longer the same, which breaks kind of a fundamental tenet of React, which is that our state doesn't change within our component. Whenever we re-render it, we give that version of our component the new value. The problem with this is we've actually changed that to-do object forever. It is now different in any component that had a reference to it or will have a reference to it. And this will work, right? This will not break for now because we do want its value to change. But if we start doing asynchronous things, right, if we start doing things out of order, we might not have the value that we expect to find here, which can be bad. And I'll show you why it's bad soon. Ooh, spooky. So for now, how do we get around this? Well, what I want to do is I want to make a copy of this object, and then I can change that copy however I feel like it. How do I make a copy of an object? Well, there's a lot of different ways. The cool way, right, the way you're going to see on lots of modern React code bases is using the spread operator, which I've talked about before, so I'm not going to go into exhaustive detail about it here. But if I have an object, right, A is 1, and I want to make a copy of this object, I can use the spread operator. What the spread operator does is it just peels off the outer layer of delimiters around the thing it is applied to. So the spread operator will take off that set of curly braces, and then I'll be left with a new object. And we can see this in action here, right? Let's make the same object point to object, right? And if I do object.a is equal to 2, then we'll see that a is 2 within this object. And for same object, a is also going to be 2, right? Because they're the same. However, if I make a copy of this, copy object with my spread operator, right, which is going to give me all the values inside of this object, but different set of curly braces. So it's going to be a different object, right? So I'm going to copy obj, our object. Then I'm going to set the value of copy object, right, which has a value of a of 2. I'm going to set a to be equal to 5. We're going to see that the value of a in copy object is 5, but in our original object, it's still 2, because I've made a copy. I'm not actually affecting the original values here. So I could do something like this. Const new to do is equal to, right? I'm just going to make a copy of t, our old object here. Then I could say new to do dot done is equal to the opposite of new to do dot done. And then I could return new to do. And this will work, right? We do have mutation here, but this is fine because we're making a new version, and that's okay, right? That's not going to change the value of the old version. However, we can clean this code up a little bit. We can make it a little bit shorter and easier to read, in my opinion, by exploiting the other nice part of the spread operator on our objects, which is going to be, oh, that's no longer defined because our page refreshed, but we can just add another key right in here. And I can say that the value of done is going to be the opposite of t.done. We're going to get a key of done here when we spread in t, but if we have two values of a key in an object, JavaScript is just going to pick the one farthest to the right. We can see that here. Make an object where a is 1 and a is 2 and a is 3. What we're going to end up with is an object where a is 3. So now I can shorten this right up, and I can just return that directly. And you may notice that we're actually in the same situation we were with our ternary operator earlier. We have an if statement that becomes one value or another value. So we can use a ternary here. I can say if t.id is equal to todo.id, then in my true case, I want to return t, but with its done value flipped. Otherwise, I'm going to return the existing t. So now we've managed to shorten this up. We've managed to replace a lot of words with a lot of symbols. And if you're new at this or you're still practicing this, this may be worse. This may be objectively worse code for you because we've replaced a lot of words that explain what they're doing, like if and else, with a lot of symbols like question mark and 3 periods and an exclamation point, right? That is not super helpful if you're still learning the ropes here. And that is fine, right? There are many people who write JavaScript every day who wouldn't like looking at this line of code because they prefer the more explicit, more deliberate, more readable to them style. And that's fine. I like this style because I've gotten quite used to the ternary operator. I just know what it means. And having this all on one line makes it very easy for me to parse it, figure out what it's doing, and then move on with my day. So that's how I'm going to prefer to write this. That doesn't mean that you have to write it this way. Right? Keep if statements if you like them. Okay, so we've got this going, and we're no longer mutating values, which is good. And we'll see why that's good in just a minute. I'm going to stop here. Do we have any questions at this point? Okay, cool. So let's try and add some things. Actually, no, I lied. We're going to talk a bit about components, right? I could write all of this inside of app. I very well could. This really will not be a very large React application. And we don't really need to split things into components if we don't have to, right? If we're not repeating code left and right, we don't gain a ton by splitting things into components, except kind of organizing our projects well, practicing that behavior, and giving things nice names. But we're here to practice, so let's split things up into components. What we can see is a very, very, very common pattern, which is to say something like, oh, okay, you know what? What I have here is, this is a component, right? This here, and actually I'm going to wrap this in a div so we can talk about that. What did I call this div? Did I call this div something? No, I did not. Okay, well, I'm going to wrap it in a div. Right? And then we're getting rid of a class name, even though it doesn't actually do anything. We're going to call it to-do list. Right? What we'd see a lot of people do here is we would say, okay, you know what? This to-do list is a component. So what I'm going to do is I'm going to make a component called to-do list. Should be capitalized. It's going to take in some props. I'm just going to return some JSX. Right? And it is going to be exactly this. This is going to be my to-do list. So I'm going to destructure my prompts because that's what I like doing. We're going to need here a to-do array. And then we're also going to need set to-dos array. Right? And that'll get us going. To-dos array. So now I can render here my to-do list, and I can give it my to-dos array, and the same thing, but with the word set in front of it. Awesome. So now we've gotten the exact same thing going, but we've made it into a component, right? And now because this code is shorter, it is better. Right? We're going to see this very, very frequently. And then people will go a step further. And they'll say, you know what, this div is a to-do. So what we're going to do, so I'm going to say to-do. This is a component. It's going to take some props that I'm going to destructure because that's what I like doing. If you're not familiar with that, I have a whole video on destructuring. So I'm going to take this div, right? Pop this in here. And this is our to-do. And it's going to take 2 props. It's going to take to-do, set, to-dos array. Oh, now we also need to-dos array. Okay. So then now I can render to-do, with prop called TODO, another prop called TODO's array, another prop called set TODO's array. Set TODO's array. Right? And now, right, this code is shorter, and that therefore means that it is better. Except this all got a lot more confusing, and not just because we've split it into multiple components, but because we haven't done this with a lot of thought in how this affects the architecture of our code. We've simply given a name to some divs and passed some props into it, right? So the problem here is, one, we get our key warning back, which is, even though this TODO is a custom component, we can still always give it a key prop when it's in a list. This is going to be todo.id. We're going to start at the top and see what the issues are here. One is this. This is just a thing that bothers me very deeply. It's giving any component access to my setState function. It just freaks me out. And the reason that this freaks me out is that I, as a developer, have seen someone else write this code, right? I don't know what this does. Either someone else has wrote it, or I wrote it more than 3 hours ago. So therefore, I do not know how it works. Right? If I look at this, I'll say, oh, okay, to-do list, right? And it takes an array full of to-dos. Okay, it probably shows some to-dos on the screen, right? Then what does it do? Well, anything. This component to-do list can do anything that it wants to, right? Because it has access to set to-dos array. It could make to-dos array the number 4. It could delete everything in there. It can do whatever it wants. And that scares me. Not only does that scare me, that makes this code difficult to understand, because now I have to go and look at the implementation of to-do list. And I come down here, and you know what? To-do has access to to-dos, to set to-dos array, right? So now I have to go read that. So I've made this much more confusing, right? And much more dangerous. So instead, what I like to do is, instead of giving access to set to-dos array, I like to write my functions up here with the state and give them good names for what they're about to do. So what to-do list needs to do, because what the to-do needs to do when it's clicked on is to toggle it, right? So I'm going to write a function called toggle to-do. What this is going to do is, this is going to take an argument, and it's going to be an ID. And its function is going to be exactly what we've written down here. Right. We're going to set our to-dos array to be the existing array, but we're going to map through it. We're going to check and see if the to-do that we're looking at belongs to the one that we're attempting to toggle. Then we're going to do our stuff. And I can just say ID here, because that's the argument that I want here. Right? I could also just, you know what, let's just make it easy. Let's just have it take the whole to-do. Why not? Keep it exactly the same. Now I can change these props, right? This can be toggle to-do. And now when we come down to to-do list into to-do, well, this doesn't actually need these anymore. What this onClick event needs to do is, it needs to call toggle to-do and give it our to-do in question. So that's the only prompt that it needs, toggle to-do, in addition to the actual to-do being rendered here. So I can simplify this. Right. Now you can start to see how we just have a lot of the word to-do running around. So now this code has gotten a lot better. It's not only shorter, but it tells more of a story. To-do list takes an array of to-dos and has the ability to turn them on and off. Nothing more, nothing less. Right? Same thing with our to-do component. Takes a to-do, ability to toggle it on and off. Right? And that's very cool. That's a better way to structure this code. However, you'll see this style a lot, and this will be called a container component, right? The idea that there's this to-do list that takes in an array of to-dos and renders them. It's a very, very common pattern. However, I'm not always the biggest fan of these container components, especially when all this to-do list really turns out to be is a div that does a map inside of it. Because what we'll see happen, right, is if I try to add more functionality to this to-do component, right, maybe I want to add a button that when we click on it is going to edit it, or maybe there's a button to delete it, right? Now I have to pass those prompts through to-do list down to to-do. So we end up with this kind of prompt soup of all these things going through to-do list for me to just have to pass them down to to-do. Some people call this prompt drilling, right? We're just passing prompts layer by layer, and there's nothing inherently wrong with that, but we just also don't have to do that, right? There's another solution to this, which is to not get rid of this map. For those of you new to this way of working with React, right, this seems like worthwhile code to abstract away because it was probably difficult to write. It took you some time, it took you some debugging, right? It took some effort to do this, so you want to hide it away. You don't want to be able to see it or break it. But this is something that you will write many, many, many times a day in React, taking a list of data and turning them into components. So we don't necessarily need a component to do that for us, because that's something that we're already going to do. What I wish I could do, right, is what this to-do list really is it's a div with a class name on it, right? Maybe it has some other stuff going on here. You know, maybe it renders some buttons up at the top. You know, it does something else. Maybe it has its own internal state. Who knows? But really, right, it's a div with a class name on it and some stuff inside of it. What I really wish I could do is I could use my components like the div. I really wished I could say, you know what, this to-do list, right, what this does is it just contains a bunch of to-dos, right? And I could do that myself. I could put this code here. This way I don't have to pass prompts through to-do list. I can just give them directly to my to-do. And I can do exactly this, right? This kind of behavior of having components inside of it is not special to the divs and the spans of the React world. We can do it ourselves. And when we do this, what React does is it gives us all of the components inside of to-do list as a special prop called children. And children, we can console log it and see what it is just going to be all of those to-do components. And we can render children like anything else that we can in React, like a number or an array of numbers or an array of components, because that's what it is. And this will work out just fine, right? Nothing seems to have changed, but we can see in this console log what children is an array of things. And what these things actually are React components, not JSXified. This is what they turn into when the JSX gets done with them, is cool, weird objects that have lots of stuff in here that I don't understand. So we're going to ignore that, right? And so this method of using children is another pattern of architecture that you will see. Perhaps too late. You know, you're going to see a lot of these container components that are really just prop pushing factories. When really, you know, it'd just be nice to have this to-do sometimes. Be able to do what I want to this. So that's what I'm going to do here. So now, right, now let's talk about forms. Now let's talk about some cool stuff, right? Is I want to have an input that I can type into and then be able to add things to this list. So I might know that there is a component called input, right? And this gives me a little field that I can type into, right? And I want to use this. I want to use this in React. The problem is, how do I know this thing's value? Oh, excuse me. Hopefully that was not super loud in the mic. Probably was. I sneeze very loud. Okay, so we've got this input that I can type into, but I want to know its value. And I'm going to cheat, and I'm going to show you its value. Just like onClick, we have other events that we can assign to elements, and on inputs we have an event called onChange. We can put our event handler here, our callback. It's going to take an event, and I'm going to console log this event. Right? And now whenever I type in here, we're going to see this event object, right? Whenever I type, and let's take a look at the values inside of it. They're gone. This is really weird if you haven't seen this happen before, and super frustrating, right? So there's things here, right? There's stuff here, but when I click on it, everything becomes null. Everything is null. The reason for that is these events, while they look like vanilla JavaScript DOM events, they are not. They're special React events. React does weird things with events to make them more efficient and reacty. And so these are actually called synthetic events. So they're slightly different. And one of the things React does in order to try to save on memory is when the event is done, it just gets rid of it, right? It doesn't have to keep those values anymore. If we want those things to stick around, then we can call event.persist. What this is going to do is it's going to mean that when I open this up in here, it's still going to have those values attached to it. Instead, normally what happens when I click on this down arrow is JavaScript will say, oh, let me see that object. But React has already gotten rid of all the stuff in there. So now it's still going to be here. Right? And so we have this big old event. And we also have our event.target. And this is going to be the actual input element, right? This is, oh, there we go. That is our input, right? And if we look at our DOM element, right, just straight up, we're talking about a DOM element at this point, this input field, we're going to see that it has a key somewhere in here called, whoop, did I do the alphabet right? Value, right? And that is the value of this input. So that's how we know the value of this thing here. And there's various ways we could extract this value, right? We could use refs, if you're familiar with the concept of refs, but you shouldn't use refs. You should never use refs if you can't. What we want to do instead is we want to make use of a pattern called a controlled input. Because there's ways of getting this value out. However, it's much harder to get a value in. Let's say as we typed in this field, right, we wanted to format it like a phone number. Or, when someone clicks a button, we want to clear this input. That would be difficult. We would have to actually manipulate this input DOM element to change its value, right? That's not very reacty. Instead, we're going to use what seems like an incredibly excessive flow, where what I'm actually going to do is I'm going to make a state variable called TODO text, right? We're going to have a corresponding set TODO text and use state. I'm going to make my new TODO text. Right. What I'm going to do is I'm actually just going to set the value on this input to be TODO text. Right? This is just a prompt to this input element. Now we're going to see that the value of its text is the value of this variable, my new TODO text. And if I type in here, something interesting happens, which is that it doesn't change. when I type this text, what's going to happen is an onChange event is going to fire. And for some brief, tiny fraction of a second, the J that I'm attempting to type will actually appear in this input. However, React is going to re-render, and it is going to say, oh, actually, the value of this input is still TODO text. You don't get to do that, and the J will disappear. And it'll actually never paint to the screen. I'm just giving you evocative imagery. Right, and if we look inside of this event, and we come down here, and we find our target, right, and we come down here, and we find our value. I actually don't think this is going to work. Yeah, if I just console log at this point in time event.target.value, however, right, this is why mutation is bad and confusing, right? We can see the value of the text that I'm trying to type here. However, React is going to overwrite it. However, what I could do is I could say, you know what? I want to set TODO text to be event.target.value. Now whatever I've just attempted to type in this field won't actually show up in that field. Instead, what's going to happen is I'm going to set the state variable TODO text to be what I attempted to type in here. And then that will cause React to re-render. And then the value of TODO text is going to be whatever I just attempted to type in there. And then React will set the value of that input to be what I attempted to type in there. Right? It's a lot of work just to be able to type into this and see it change. It seems like too much work. However, this gets us some very neat things, which is that we can interact with this variable like it's any other piece of information with React, and it's automatically synced back and forth to the value of this input. So I could have a button, call it reset, right? What this is going to do is on click, it is going to set TODO text to be an empty string. So if I were to click reset, boom, the input clears. That would be very difficult to do without actually having a reference to this actual element to be able to set its value. Instead, in this controlled format, where the value of this input is always the value of one of our state variables, we can very easily change it using any React code that we feel like doing. And that is why we call this a controlled input. Right? We have control of its value in all points and times. It never has its own value. It has the value that we give to it. Any questions with that? All right, cool. So I'm going to do a thing that you're going to do at some point. You're going to be confused about it. Where, right, I don't want to give this any starter text, right? I just want people to type whatever they feel like in there. So I'm going to get rid of that. And then I'm going to hide my console, right? Because I don't need it anymore. And I can type in here, right? And all this works. I can hit reset and it clears. So my code is good, right? It's perfect. No problems. React has yelled at me. React has gotten mad. And it gives me this kind of cryptic warning. It says a component is changing an uncontrolled input of type undefined to be controlled. Input element should not switch from uncontrolled to controlled or vice versa. Blah, 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 blah. It links me to the docs that, right, I'm never going to read because I hate Henry and I don't read docs. The React docs are right. Read them. But what this means is that, right, our inputs don't have to be controlled. I don't have to use this style. However, we're switching. We're changing horses midstream, right? Which is an expression that I don't think anyone has ever had to do that would see these videos. But I think we all know what it means. So the problem is that the original value of to-do text, in this case, when I don't give you state of value, right, this is going to be undefined. And the problem with this is that, let's say app takes some props, right, and we do props.value. If this isn't here, its value is going to be undefined, right? That's just how objects work, right? So React doesn't actually know if you tried to give a value to this input. And because it sees undefined, it's going to assume that you didn't, and that this input should just be a normal input element that when people type into it, its value, right, the mutable value on that element will change. The problem is, as soon as they type into it, you set the value of to-do text to be not undefined. You make it a string, and now React has to set the value of this input for it, right? It has to use this kind of cyclic flow of being a controlled input, and React doesn't like that switch. And I've never actually run into a bug caused by controlled input switching or not. And I'm not going to lie, I've ignored this error before because it was annoying to fix, but it's bad practice. We don't want warnings in our code. And this is usually very easy to fix. All it means is changing this undefined into an empty string. That way React knows from the get-go that this input, don't need this anymore, is going to be controlled by us, and it will never have its own intrinsic mutable value. It's just going to have the one that we give to it. So that's what a controlled versus an uncontrolled input is. And later in another video, I'll talk about how to make these less annoying. So we've got our input here. Now what I want to do is I want to be able to add to-dos. So I'm going to get this button back, and instead of making this a contrived reset button, right, I want this to add to-dos. What this is going to do is instead of on click resetting this field, I want to add a new to-do. So what we're going to do is we're going to say, what I want to do is I want to add a new to-do to this array. So first we have to make a new to-do. It's easy enough. Const new to-do. It's going to be an object, right? We know the value of title is going to be the to-do text, which luckily we have in a state variable, so it's very easy to reference. Its status of done is going to be false. If we're adding it, well, then it's definitely not true. And now we need to give it an ID. So let's give it an ID of 6, right? We don't have any IDs of 6 yet. Problem is if we add more than one to do, well, now we have 2 IDs with the value of 6, so that's not going to work. What I'm going to see some people do is they're going to say, aha, I need this value of ID to be different, so I'm going to type math.random, and that's going to work. And the problem is that will work most of the time, but not all of the time, right? If you flip a coin twice and it comes up heads both times, that's still a random coin, right? You can get the same value out of a random sequence more than once, and there's no problem with that. And with this math.random function, it's pretty unlikely that you're going to get the same value twice if you're only handling, 20 to-dos, but I don't like writing code that could be wrong sometimes. And having 2 keys with the same value is pretty wrong. It can cause some weird stuff to happen. So instead, there's a lot of different tricks we could do. We could use an iterator function, right? There's ways of making sure that whenever we call a function, it's always going to give us a different value. Or we can call date.now, which is going to give us the current number of milliseconds since like 1980. Right? So as long as we don't create 2 to-dos in the exact same millisecond, this will give us a unique number. And that's good enough for me right now. So we've got this going. So we've got our new to-do. And so now I need to add this to-do to the end of to-dos array. And some of you might know, aha, if I want to add a value to the end of my array, right, then I can use to-dos array.push, because push adds values to the end of an array. Right? So I could do this, right? I could write this here, I could click add, and then, oh, that appears to not have done anything. Let's make sure this is right. Right, console log, new to do. I just want to make sure that this onClick event is running. Right. Okay, so it's running, but I don't actually have a new to do. Oh, I know what I've done. Right, I've added the new to do to this array, but I haven't actually called set to dos array. So this array isn't actually changing, right? I haven't asked React to re-render yet. So let me type this in and let me click this button. Oh, okay. Now I've gotten a bug. Okay, this isn't actually the lesson that I wanted to teach. So I've added, let's put this away for now. Right, okay, so I've written this in here. I've clicked this, right? That seems to be working. Let's console log to-dos array and see what's happening here. Right? Oh, my array has 4 things in it now. And if I click this again, now it has 5 things in it. But why don't I see 5 to-dos on my screen? That's super weird. Let me just click one of them. Now the other ones have shown up. Right? And that's crazy. It doesn't make any sense. I found a bug in React. I'm going to now tweet at Dan Abramoff and tell him that his software is bad. Right? But it turns out the bug is me. It was me the whole time. I did a very bad thing. The very bad thing was that I used mutation. Right? We talked earlier about how mutation can lead to unintended consequences in React, and that's exactly what's happened here. Is I have changed the value of to-dos array, right? I've actually added an element onto the existing array, changing all of its past values and all of its future values. The problem is that React doesn't know that that's happened. React doesn't know that to-dos array has changed and that it needs to re-render, right? It doesn't have some special way of watching to-dos array and seeing if it changes and then re-rendering. The way it does that is with this set to-dos array function. We explicitly tell React, hey, I'm changing to-dos array. Please re-render with this new value. Right? And I haven't done that. And that's why when I click add here, right, the value of this array changes, but React doesn't know. And it's not until I force a re-render by changing an unrelated piece of data that React does perform the re-render and the new values show up because they were just in that array. Right? And we might think that we can do this then, set to-dos array to be the new to-dos array, right? The one that we have pushed this value into. And if I type some stuff in here and I click add, right, we'll see that we now have 4 things in here, but we still haven't gotten the new one to show up. We can double check, click this, there it goes, right? And the reason this isn't going to work is because of some stuff I alluded to earlier. And that's because of how we check equalities, right? I mentioned that one of the reasons that we have these IDs for the to-dos is so that we can tell if we're working with the same to-do or a different to-do, right? I can check if these 2 IDs are the same. What I can't always do is check if these 2 objects are the same, right? And that's because of how we actually perform equality checking in React. Right? There's equality by value, right? Which is 1 equal to 1, right? Numbers, we can inspect their values. We can know if 1 or 2 are different or not. Same thing as with Booleans, right? We know true is not equal to false. We can also do this with strings, right? We know the string test is equal to the string test, right? That's just true. However, what if I have an array with a value of 1? Is that equal to another array with a value of 1 in it? Well, JavaScript is going to tell you that it's not, that these aren't the same thing. And that might seem confusing because for all intents and purposes, they look the same, right? They have the same values in there. The problem is that we're not using equality by value here. We don't care about the values. We care about what it references. In the same way earlier, where I said, right, our object of A is 1, and then I made the same object is equal to object, right? And if I change the first object, right, if I make A equal to 2, that also changes the variable same object because they actually point to the same object in the memory of my computer, right? They're literally the same object. These variables are not two different things. They're both references. They're both pointing to this one actual object that has the value in it. So if I did obj is equal to same obj, right? Triple equals, always triple equals. That's going to be true, right? However, if I copied this, again, copy object is equal to, using our spread operator, this copy trick, right? Is copy object, even though it has the same values, is that equal to obj? It is not, because these are two different objects that I can modify independently. Right? These are two different things. This is equality by reference. They point to two different objects in the memory of my computer. And that might seem silly, right? Why can't we just check and see if all their keys are the same, or if all the elements in the array are the same, right? Well, what if our object looks like this? A. Oh, this is actually another object. Oh, and this is actually another object. Oh, and this is actually another object, right? We now have this problem of how many layers deep do we go, right? And this can get very expensive if we have an array with 10,000 objects in it and compare it to another array that has 999 of the same objects, but one of them is different, like way deep down, right? That's a very expensive thing to check. So JavaScript doesn't. It uses this equality by reference. And this is something that React does when we call setState. If I have a state variable, let's say count and setCount, right? And its value is 4. And then I call setCount of 4. Well, React is fast. And one of the reasons that it's fast is because it tries to avoid re-rendering where it can. And so what it's going to see here is that, oh, the value of count, it actually already is 4. So there's no need to re-render this component because nothing is actually going to change, right? We already have a 4. We already know what the output of this component looks like when count is 4. So I'm going to skip the re-render here. And the same thing is occurring here when I say set TODO's array to be TODO's array. This is the same array. The stuff inside of it has been modified, but when React does the equals checking here, it's going to see that it's the same array in memory, right? And so it's no longer going to know that it needs to re-render. It thinks it has the same data. So that's that bug that we're experiencing. That's one of the reasons why mutation is very bad in React. Instead, what I want to do is I want to add an element onto a copy of this array. There's two ways we can do this. One is using an array function called .concat, which is the same as push, except it makes it a copy of the array and returns that value, right? I can do this, and this will work perfectly fine, right? However, if you're kids, or the cool React kids, they're going to use the spread operator to do what is essentially the exact same operation, right? It's going to look exactly like this. This will strip off the square brackets of TODO's array, give me a new array, but this time new TODO is on the end. That's just the cool kids way of doing it with the spread operator. Basically the same thing though. And we can inline this object too. Again, very much a cool kid way of doing this. And there we go. Now I can click here and add this TODO to my list. And it works like all the others. So we've got that. However, this input's bad. When I type in this, I can't hit enter to add this value to my list, right? But that's a feature that I've gotten pretty used to. So I can go ahead and I can Google React, do input on enter, and I'll find a very helpful Stack Overflow answer that's going to say, oh, there's another event listener we can have called onKeyDown, right? And this will give me an event value, right? And you can do event.keycode. And the one for enter is like 42 or something like that. Nope. 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 We're not going to do that one. We're not going to do that one. This is why it's really important to not forget that React is not an island, right? We're still writing stuff that goes into a browser. And people have thought about things like forms before React has existed. So there's an element called a form that we can use here. And this is how we actually want to manage that kind of event. Because what happens if you have an input in a form and you hit enter on it, it is going to trigger a form submit event. And what's normally going to happen here is I'm going to give this input a name so that autocomplete can work in it, and also because I need it to do a thing. So I'm going to call this TODO. And what normally happens, if I type into an input and I hit enter, my page refreshes, and I get this query parameter added onto the end of my URL, which is the name of the input equal to its value. And we don't want this in React for multiple reasons. One, we never want to refresh the page, right? Then we have to get our whole big SPA again. That's bad. Two is that half the time we do forms, it's a login form and someone has just typed their password into that field. And we do not want that to show up in their URL, right? That would be bad. This used to be necessary, right? This was a reasonable default behavior back when all web applications were server-side, that refresh would submit that data to a server, by being in the URL, that would end up on your web server and it would account for that and it would do something with it. But now we don't want that to happen. So what we can do is we can listen to submit events on our form. Right? And so I can write an event handler. It's going to take the event. I'm going to call event.preventDefault. And this is not a React thing. This is just a normal thing with our DOM events. What this is going to say is, hey, event, whatever you are normally going to do, like refresh the page or change some value or whatever, just don't do it. So now, when I type in here and I hit enter, right, nothing is going to happen. Right, nothing is going to happen because I've prevented it. But now I can hijack this event and make it do whatever I want. In fact, I'm going to make it do the same thing that this button does. Right? So now I can type in here, and I can say new to do, and I can hit enter. Oh, and I get 2 of them? What? So, while it is nice that React is not an island and that we have things like form elements that already exist, we do have baggage to take into account, right? The same way that this form existed before client-side applications, so it does a weird page refresh thing, Forms has its own convention. And that is the way a form submit event actually works is that when I hit enter, what this is actually going to do is it's going to find a submit button within my form, and it is going to click on the submit button. And then that button being clicked on will fire the submit event on the form. And if you don't believe me, you can watch that happening by like console logging all the events that go on here. So what happens is when I hit enter here, this actually clicks the add button, which then fires the form event, right? Which then adds the to-do twice, which is something that we don't want, right? Seems bad at first, but what this really means is this button does not need an on-click event handler. This button, when we click on it, is going to fire a submit event, whether we click on it or we hit enter in a field. So now we've simplified this greatly. And we can say explicitly the type of this button is submit, which means when we click on it, right, it's going to fire a submit event. We could also give it a type button, which means, hey, it's a button. It might do something. It might not, right? But just let it do its button things. When it has a type button, it will not submit the form. When it has a type submit or no type, it will submit the form. So that is that. But now I want to clear this input. Well, because it's a controlled input, super easy to do. I can just set to-do text to be an empty array, and we're all good to go. And because I have control of all this value, right, it's very easy for me to add logic on top of this. So if I hit enter with this empty form, right, we get these empty to-dos, which are ugly. So I can just put an if statement in here. If to-do text is not equal to empty string, right, then do the things. Okay, so then I actually have to put text in here. Can't submit an empty one. All right, we can go ahead and we can style this up. I already have some things prepared. Class name is equal to styles dot to-do form. Class name is equal to styles dot to-do input. And then this button is called add. Cool. And I think this form is supposed to go inside of this main. Excellent. All right, now we have this cool looking thing. So I want to talk about the architecture for a bit, and then we're going to call it quits because this has gone a bit long. Again, we might want to split this up into a component. So I could go ahead and say, oh, you know what? I'm going to make a component. I'm going to call this to-do form. Right, and this is going to take some props, which I'm going to destructure. But it's going to return some JSX, which is going to be my form. Right, so I'm just going to take all that, put it in here. Right, oh, it's going to need some props. Right, just to translate this over, it's going to need the value of to-do text. It's going to need to have the value of set to-dos array and set to-do text and to-dos array. Perfect. Right? So then I can come in here, I can render my to-do form and give it all of those props, which is not what I want to do for a lot of reasons. One, that's too many props, way too many. Two, I don't want to give it set functions. No, it's very bad to give it set functions, right? That's not what I want to do. I want to restrict what this form is capable of doing. Okay, so I'm going to think about this. And I'm going to try to pare this down to the essentials, right? So what is this submit actually doing? Well, it's adding a to-do to the list, right? Right. So let's write a function and call this add to-do. What this is going to do is it's going to take some text, right? And that is going to do what's actually in here. Right, it's going to take some text, and given that this text is not empty, it'll make a new to-do for me. Right, that seems cool. So now I can render my to-do form, and I can give it an add to-do thing. And that's actually everything this to-do form needs to know, right? Because what I'm going to do is I'm actually going to make this state local to the to-do form. Something that we see over and over again in React, right, is needing to lift our state up. Whenever we need to share state with multiple components, that means we need to lift it up into a parent and then pass it down as props. And so we can get into this habit of just putting all of our state in our root component, right? Our main app just has all of our state in it all the time, right? And that's good because it makes it very easy to share state around, but it's bad because it makes our state management very complicated, right? All the states in here, we have to pass props everywhere, right? And it can get confusing. When really, all this app actually needs to know is when we're ready to add a new to-do and what its value is. It doesn't need to know the value of this input at any given time, right? It just needs to know what it is when we submit it. So we can keep this state local to the form component. And then, right, what this can do is when we're ready to add this, I can say, well, I have my add to do prop. We could even call this on submit, right? We could ape that style, right? We can say add to do and then give it the value of to do text and then clear it out right within here. Add to do doesn't even need to know about that, right? Get rid of this event.persist. So now we have here, right, this state local to this component, but when I hit enter and I submit this form, we're calling our add to do callback function, which is going to go ahead and add the to do to our array. And we see that show up right down here. Something I neglected earlier is something concat cannot do is reverse this order so that we can add items to the beginning of the array so that they'll show up on the top. Right. So there we go. There is our to-do app. There is our basic input interaction. And there is some discussion on different ways to architecture this application to get components that take only the prompts that they need and still be very readable. So, is there anything we'd like to talk about before we wrap up?
I do have a sort of related question just about where to keep your state, specifically in the context of other state management systems like Redux.
Yeah.
I've run across, when I was helping some other students, I've run across students with sort of two very different approaches. One is to have all of your form inputs managed by Redux and the Redux store. And the other is to do it more like here where you have component state and then you bounce the object that's created up to the Redux store.
Yeah.
Do you have any opinions on, specifically in the context of Redux or a state management system like that, whether it's better to make everything Redux or to have a mix of state management.
Yeah. So my Redux opinions aren't great because I have not worked with Redux, at the scale of a large commercial application. So there's certain, performance things that I can't really comment on. But I do appreciate the idea of the entire state of your React application being inside of the Redux store. That way you have access to the full power of your reducers and stuff in there. However, that's also one of the hardships of using Redux is just keeping everything in this enormous store, right? And it just gets very complicated to handle things, and you can have, stuff way over here modify the values of stuff way over there, and it can get confusing to keep track of. And there's tools to mitigate this, right? We can split our store into, multiple different objects and do other things. So, right, there's no hard and fast rules, but we can generally delineate state to be either local or global. So this input, right, I would consider it to be local state. It is local to that component, right? No, nothing else needs to know about the value of this input, right? In the same way that if I had a toggle component, right, the true or false value in that toggle state would also be local to that toggle, right? Nothing else needs to know about it. But that doesn't mean that we can't expose that state to the wider world, right? Toggle, much like this form, might take a callback whenever its value changes. It might also take an initial value, right, that might be controlled by some state somewhere else, maybe inside of our Redux tree, and they're kept in sync that way. But we can still keep state local to that component. And the advantage of this, the advantage of trying to keep your state low and local is that, I'm going to say this naively because I don't know, is that it's going to keep some of our re-renders to a minimum, right? When I type in here, the whole application is no longer re-rendering. Only this form component is performing a re-render because I'm not changing the state at the app level, right? And so if this list were very long, that actually becomes important performance-wise. And same thing with Redux, right? If I'm changing stuff in my store, then everything that subscribes to it, and re-renders start happening. However, the problem with keeping your state low is that it can be a pain to bring up, right? If this input, right, if this state is a bunch of layers down and I need to share it with some sibling way off in my tree, right, now I have to bring this state very high up and pass its props very many layers down, and that's a pain, right? And it makes our state difficult to manage, which is what Redux attempts to do by saying, you know what, just put everything in there. Let anything get what it needs, right? That's not our concern. React is the view layer of our application. It just needs to take data and render it. It doesn't really care how that all works. And so there's that trade-off there. I tend to, with all that being said, with all the hemming and hawing with no results, I tend to try to keep my state as local as it can be, because that helps me write components that are going to be more reusable by thinking about, like, okay, what state does this component need to function? And then what state does my application need? Those are often two different things, right? This component might be more complicated. We might have, like, some prefix value in here. We might have some, knobs to give it different priorities, right? And this might have some complicated form state. We might even assign it, a difficulty value, right? Like this is worth 12 points. But because this is an input, right, that textual value of 12 is a string called 12. It's not a number yet. But when we're ready to submit it, right, we need to parse that into a number. So the state that our application cares about, that number 12, versus the state that this form cares about, the string 12, are different. Right? And so now, instead of trying to reconcile those things to be the same and write a more specific component, I have a more general one, right? So that is what I like to try doing. Doesn't always work. Still need to lift state up from time to time. There's cases, where like I'm using the context API and it's like, oh, I just have to keep lifting things up because like so many things need access to this, and maybe I should have used Redux. But this is the trade-off we make, and this is what experience is all about. The important thing is rather than to be in this situation, right? Writing our side project, writing our tutorial, and going, should this be component local? Should this be global? What should I do? Let me just, right? This is a trap that I constantly fall into. It's like if I evaluate every possible outcome, I can do it correctly. When really what we should be doing is trying to fail quickly. Just pick one and do it until you get annoyed with it, and then you have to fix it because it's bad, and now you actually know the trade-offs firsthand. And both of them are going to end up being bad in different ways, and that's how you start making informed decisions about these. So, yeah. Does that answer your question?
Yeah. Yeah, that's. I was mostly just interested, sort of in an exploration of the pros and cons. That matches a lot of my experience, especially the part about trying to think it through all beforehand. When really what you just need to do is do it and then fix it if it needs fixing sometimes.
Yeah. Plus, if you do something bad and your coworkers don't catch it during a code review, was it even bad to begin with? Ha. I'm guilty of that. Yeah, occasionally. Yeah. So that was our TODO project. I might revisit this offline to show some of the other stuff that I had planned, with like editing these things and some more form stuff. But we will see. So thank you all for coming.